So guys, in today's video, I am telling you about the array reverse and this is our Array Dsa part 37. So we will be do our all the things in the life. Okay, our daily life will become okay, or one day left and one day our life will become. So now in today's life, I am telling you about the part 37 by the name of array reverse. So let's start and let's talk about what are array reverse and what is about it, and we will be also using examples of the C++ and I will be also explaining you these examples. So let's start and let's talk about array reverse. So let's start. Now if we talk about array reverse, it is giving me one array, okay, ARR square bracket. What is our task? The task is to reverse the array. Please highlight the reverse word because it is a very main word. Reverse the array, and reversing an array means rearranging the elements such that the first element becomes the last and the second element becomes the second last, and so on. So I hope you understand, means the first element becomes the last element and the second element becomes the second last, and so on. So this is one example that has been given me, in which he wrote it down. Here he created one array by the name of ARR square brackets, in which he wrote it down 1 4 3 2 6 5, and the output has been coming in the curly brackets 5 6 2 3 4 1. Why? Because the first element 1 moves to the last position, the second element 4 moves to the second last, and so on. If you see here, this is one starting 1 4 3 2 6 5. So 1 has been gone into the last and 4 has been gone into the second last, 3 has been gone to the third last, 2 has been gone to the fourth last, 6 has been gone to the fifth last, and 5 has been gone to the sixth last. Here you can see it means ascending to descending or descending to ascending. It is like this. Okay, now this is one example one. I hope you understand because this is a very easy example. So if it has been given you one more example, here he created one integer array by the name of array square brackets, in which he wrote in down curly brackets, in which he wrote in down 4 5 1 2, and the output has been coming 2 1 5 4. Okay, why this type of output has been coming? Let me explain you. Because the first element 4 moves to the last position. If you see here, the 4 has been going into the last position, and the second element 5 had been going to the second last, and so on. If you see here in the starting, here the input has been 4 5 1 2. So 4 has been going to the last element, 5 has been going into the second last element, 1 has been going to the third last element, and 2 has been going to the fourth last element. If you see here, so I hope you understand what it is trying to say. So let's unzoom it. So let's come down. Naive approach. Now using a temporary array slash o square bracket and time and o rounded brackets and space. Now the idea is to use the temporary array is to store the reverse of the array. First, we want to create a temporary array of the same size as the original array. Number 2, now copy all the elements from original array to the temporary array in reverse order. In which, in reverse order, okay, please highlight it, this reverse order, because the topic is on about reverse order or reverse. Now number 3, finally copy all the elements from temporary array back to the original array. Then these are the 3 ideas to use a temporary array to store the reverse of the array. Okay, these are the 3 steps working. Now below is the implementation of the algorithm. This one implementation of the algorithm. This is the C++ code. So let's run this code. So in this code, it is giving me the output 5 6 2 3 4 1. Let's see why. So let's run this code. So first of all, we open my Rapplet. Like you all the people know, in this series we are using a Rapplet. Okay, and then you will be open the Rapplet, or you will be first of all sign up in, or I am login. So because I have already made it the account on the late in the Rapplet, so now it is taking a little bit time. So now here I am signing in, so I am signing from this account. So now it is taking a little bit time. So now it is taking a loading. So let's wait it down. So now it has been taken the loading. So this is my, where is my C++ file? So let's delete one file from here. Now let's create a RAPL. Okay, home, create RAPL. Now home. Here is our C file. So let's run this code. So you will be running this code from here. Okay, Then you will paste this code and then you will be running this. Okay, very easily, and then it will be give you the this type of an output. Let me show you how. 5 6 3 2 4 1. Okay, now why it is giving you this type of output, let me explain you. Time complexity 0, and it's comping the elements to a new array. It's a linear operation, and here we created an auxiliary space 0, and as we are using an extra array to store the reverse array. And if it is not running in your Rapplet, so you will be make your file into the Visual Studio Code by the name of index.c++, sorry, not C++, index.cpp, because whenever you make any file of the C++, you write cpp. Okay, now you will be running it from here, then you will be running your code from here, from the terminal. So then it will be give you the output. So never run, do not run, so a always run. So then it will be run, and then it will be give you the output here. Okay, so it is giving me the error. Let's see what type of error. Okay, my extensions are not downloaded, okay, of the C++. So you will be downloaded from here, then you will be running, so it will be not give you the error. Okay, like packages and then all the things. Now let's come down here. Now expected approach using 2 pointers, 0 rounded brackets and time, and 0 rounded bracket 1 space. Now our idea is to maintain 2 pointers, means left and right, such that left points of the at beginning of the array and right points to the end of the array, while left pointer is less than the right pointer, and we want to swap elements at these two positions. After each swap, increment the left pointer and decrement the right pointer to move towards the center of the array. This will swap all the elements, means it will be swap all the elements in the first half with their corresponding element in the second half. And this the working. Here's one implementation it has been given me, and these are the C++ program which it has been given me. So you will be run this, and it will be give you the same output which it has been given me the above. So you will be log out from here, and then you will be also log in from the new account, like I am logging in from the new account. So now, because in that account there is my limited usage, so that's why I do not make one more file. Okay, now there is a limited 3 files you made it. Okay, now you will be run it from here. You will be here, you will be make your C++ file, and then you will be run it very easily. Yes, okay, you will be run make your C++ file, and then you will be run it. Now here you can choose a template. Let me choose C++. So here I choose a C++, and then let me create a app. So when I create it, so it will take a little bit loading, so it has been open it. So you will be run this code from here. So it is taking a loading. So now I am pasting this code. So here I have been explain each line of code with using the comments. So here you can see it is giving me the output 5 6 3 2 3 4 1. Okay, why? Because let me show you. Here we created one array in which I wrote in a 1 4 3 2 6 5, and the output has been coming 5 6 2 3 4 1. Why? Because it has been first 1 is come in the last, okay, and then 4 has been come in the second last, 3 has been come in the third last, and then 2 has been come in the fourth last, and 6 has been come in the fifth last, and 5 has been come in the sixth last. If you see here, you can see it like this type of, that's why. And it had been also explained you the each line of code. Now here we use the time complexity 0, and as we are visiting each element exactly once, and here you use the auxiliary space 0 rounded brackets 1. Expected approach by swapping elements 0 rounded brackets and time, and 0 rounded bracket 1 space. The idea is to iterate over the first half of the array and swap each element with its corresponding element from the end. So while iterating over the first half, any element at index I is swapped with the first with the element at index rounded bracket n minus I minus 1. And there is one implementation of the algorithm. It has been given me the same algorithm. So you will be running it. So it will give you the same output 5 6 2 3 4 1. If you see, but it is here we are using different methods to print the output. Okay. output are becoming same, but we are using a different method. So in this method we use the time complexity 0 n, and in this the loop runs through half of the array, so it's linear with respect to the array size. Here use the velocity space 0 1, so no extra space is required, therefore we are reversing the array in place. Alternate approach using the recursion 0 n time and 0 n space. Now our idea is to use recursion and define the recursive function that takes a range of array elements as inputs and reserve it inside the recursive function. First, we solve the first and last element. Number 2, we recursively call the function with the remaining subarray. So here we give the implementation also. So it will, in this implementation, it will give you the same output 5 6 2 3 4 1, but we are using a different method to print this output. Okay. Now in this we use the time complexity 0 n, in which the recurrence relation will be t rounded bracket n equals to t rounded bracket n minus 2 plus 0 rounded bracket 1, which can be simplified to 0 rounded brackets n, and we use the velocity space like 0 n as we are using in recursion stack using the inbuilt methods 0 n time and 0 n space. Now our idea is to use inbuilt reverse methods available across different languages. Okay, and these are the codes which it had been given me, and here we use the, let me explain you this code in which this is our C++ program to reverse an array using the inbuilt methods. In this code we use the inbuilt methods to reverse an array. Okay, now in this we use the time complexity 0 n to reserve the better as linear time complexity, and velocity space 0 1 to additional space is not used to store the reverse array as the inbuilt-in array method. Swap the values in place. So in today's video we cover our part 37 in which we run about array reverse. So I hope you enjoy this video. If you enjoy, so like, share, subscribe, and if you enjoy this live streaming, so please like, share and subscribe, and please comment down how you will be like this video or not. Okay, so now let's meet you in the next live stream. Okay, maybe tomorrow we meet, then tomorrow or from tomorrow to tomorrow. Okay, but see my live stream. Okay, so this live stream has been ended, and now let's meet you in the next live stream. So now for today, good